Alright, this is an integration Cal 2 question. We want to find the area of the region of in the first quadrant bounded on the left by the y-axis, below by the curve x equals 2 square roots of y, above the left by the curve x equals y. Wait. Let's use different colors and then I can do that with the lines. So x equals y minus 1 squared, and then above right by the line x equals 3 minus y. Of course, this would be a lot prettier if you use a graphing program, but I'm just going to graph something very quickly. So there's my x equals 2 square roots of y. The reason why you definitely want to graph this is because you're going to see here in a minute of numbers that I'm going to throw out, and you'll know why. And then let's say 1's right there. I'm going to have my x equals y minus 1 squared. And then finally, my line, definitely not drawn to scale incorrectly, but very quickly. Just so now you can see what we want to do is we want to find this area inside here. Alright, well, there's a couple of things we can kind of do to manipulate this a little bit. First is we can find these values, because we're given all of these are x's, so in other words they're equal. So the first thing we could do is we could say, get another color here, is we could say y minus 1 squared equals 3 minus y. And we could solve this, and this again is just helping out to see where the values are on our graph. We could solve this by squaring our y minus 1, so that's y squared minus 2y plus 1 equals the 3 minus y. And then continuing to solve this, y squared minus y minus 2 equals 0. And now we can factor this into y minus 2 and y plus 1 equals 0. We only know the one we're going to use is y equals 2. In other words, I'm trying to find where I'm going to bound these for my limits of integration. And why am I not going to use this? Because we're only looking at the first quadrant. Alright, and so then another thing, now we can also find our second bound is, so let's just call that our first bound. And now our second bound is by taking 2 square roots of y equals 3 minus y. I probably would square both sides first. So I'm squaring, I'll go ahead and write it out. I'm going to square that, which is 4y equals 9 minus 6y plus y squared. And of course I can move everything around. 0 equals y squared minus 10y plus 9, which can be factored into y minus 9, and y minus 1 equals 0. We can pretty much look at our graph up here. That's why I said it's good to deal with the numbers, that we know we're not going to use y equals 9, so our limits are going to be 1. Alright, so to find these two areas, I don't guess we need to really see the graph anymore. So to find these two areas, what we can do is we can find our 2 square roots of y bounded by our y-axis, which is just the same thing as 2 square roots of y, or as you're going to see, put this in y to the 1/2 exponent. So because we're bounding this between 0 and 1, our first area, we have 2y to the 1/2 dy, which of course gives us, bring the 2 out front, 2y to the 3/2 over 3 from 0 to 1, which is simply going to be just 2, we throw out the 0 1 of course, plug in the 1 So we get 2/3. Uh-oh. And this gives us 4/3 for our first area. I'm just doing this in 2 steps and instead of one big long step. So our first area is 4/3. And then our second area is, we just found out, we're going to bound this by 1 and 2. And we have our two equations, 3 minus y minus 1 squared dy. So away we go. This is going to equal, our 3 is going to become 3y. Our y is going to become y squared over 2. Then we're going to have our 1/3 y minus 1 cubed from 1 to 2. Now we get to just start plugging in values. And so I plug in my 2 minus 2 squared over 2 minus 1/3 2 minus 1 cubed. And then of course all of this minus, do the same thing and plug in 1s. So minus 1 squared over 2 minus 1/3, 1 minus 1, oh how nicely, so at least that one piece goes away. So all I've done here is plugged in my 2 and then plugged in, my 1. And if you go through all these calculations, I'll leave that up to you, but you should get to the point where, I'll give you kind of a step before because I did go through lots of steps. You should get to 6 minus 2 minus 1/3 minus 3 minus 1/2. You can probably see that very quickly because that 0 goes away. And you should get 7/6 out of this. So now you just add this area and this area. 7/6 plus 4/3 equals, of course, 7/6 plus 8/6, 15 over 6. Or you could reduce it and get 5/2 for your final answer. True.